Okay, grade nines. Let's take a look at another lesson. This is going to be lesson 6, and lesson 6 includes information from 2 sections of the textbook. So if you do have the textbook at home, it's section 2.3, human niches and population, and section 2.4, ecosystem services. And there's a series of homework questions there if you have the textbook that you can take a look at, and hopefully you're able to do some of those questions because they're going to help you. But if you can't do them because you can't get a hold of the textbook, and I haven't been able to get one available to you guys yet, then it's no panic. We're going to do the best that we can with the resources that we have. Okay, let's move forward here. The human niche. So we talked about niches before. That's the role that organisms play in an ecosystem. What about us? We're living things, we're organisms. We're special in a lot of ways, but we're not that much special. We're not that much more special than other organisms. We have an impact on the environment. We're living things. We evolved. We need resources. We consume resources. We interact. That's us. Okay. But here's a big difference. We are able to adapt to many different ecosystems and create our own niche within them. We have more control over our environment than most other species do. Okay. We can change the environment to suit our needs, but it's important for us, since we are capable of doing that, that we be mindful, that we inhabit ecosystems in a sustainable way. Now, what does that mean? What does sustainable mean? Okay, sustainable means that the use of a resource does not lead to long-term depletion or affect the diversity of the ecosystem from which the resource is obtained. That means we are using a resource in a way that does not use it up, okay, so that we don't run out of that resource, and that impacts other organisms, plants, animals, microscopic organisms, as little as possible. Okay, as little as possible. How are we as a species doing at this? What grade would we get as a species for using our resource in a sustainable way? Probably not a high grade. Okay, one of our key resources is petroleum oil. Okay, that black oil, crude oil that we get out of the ground and that we refine to make plastic and gasoline and a lot of other products out of. We don't use that in a sustainable way. We burn a lot of it, and that will run out. Probably at some point in the next 100 or 150 years, that will run out. Okay, coal and natural gas are similar ideas. We're not using them in sustainable ways. And when we get those things out of the ground, we completely destroy the natural ecosystem that we're mining out of. Okay, so we are not using our resources in a very sustainable way. And there are a lot of other examples of ways that we're not using our resource sustainably. And I think a big push now, when I was at McMaster University, let's say 10 years ago, but it was longer than 10 years ago, a big push was sustainability. Which of our practices as a species or as countries or as a planet are unsustainable, and which practices could we shift to that are more sustainable? Okay, instead of getting electrical energy from coal, what would be a more sustainable way to get that electrical energy? Okay, maybe solar power, maybe wind power, maybe hydroelectric power, which we do use here in Southern Ontario, but other places don't. Okay, so we want to be thinking about that in that way. Okay. Because here's the thing, the way we use gasoline, the way we use crude oil and coal and natural gas, what we would call fossil fuels, we're meeting our needs now in the present. We have enough energy now, today, to do all the things that we need to do. In 100 years, will we have enough energy using those same resources to do all the things that we want to do then? I don't know. The question is difficult to answer, but most scientists agree we are going to run out of those fossil fuels within a century or less. Okay, so the decisions that we make now about how we use our resources, and it's not just fossil fuels, there's lots of resources that we're talking about, but the decisions that we make now in terms of how we're using our resources will affect society in 50 years, in 100 years, in 200 years, in 300 years. And that is in terms of the age of the Earth and the age of our species, human beings, not a particularly long time. And so these concepts, although may not affect you in your lifetime, they may affect you in your lifetime, but they may not. Okay, they're very prescient, they're very important, and we're running out of time very, 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 very quickly. Okay, let's talk about humans and our carrying capacity. Human population currently stands at more than 7 billion, with a doubling time of about 60 years. Okay, and you got this graph here, a couple of graphs here. Okay, and you can see on the left, I hope I'm pointing left, but it should be on the left hand. So if it's not to the left, if I'm not pointing to the left, ignore my hand. But it should be on the left hand side of our PowerPoint here. There's a big graph that shows the world population for the last 2,000 years. And what do we notice for the last 150? Huge, huge exponential growth. Up until the mid-1800s, very gradual growth, okay? But since the 1800s, rapid exponential growth, okay? So there's three things that we want to point out, and that's why to the right, and I hope I'm pointing to the right, but if I'm not, we're going to look at the right. What the right does is it magnifies a section of that graph to look at the last 1,000 years, okay? And you can see this big dip. The first thing we're going to talk about is this big dip. And you can see that on both graphs. There's this big dip. What is that dip? That looks like it depleted huge portions of our population during the 1400s. Well, that was the deadly plague, the bubonic plague or the Black Plague. Okay, that was a plague that depleted millions of people. Okay, it's almost difficult to comprehend how many people died during the Black Plague, but that is a big dip. That the fact that that plague shows up on this graph, that noticeably means that was a huge historical event that demolished our population. And for a long time, okay, took a while for our population to recover. Okay, let's say 100 years, 200 years for our population to recover. And that may seem like a long time because you're not going to live to be 200 years old. Okay. But if we look at the grand scheme of the last 2,000 years, that's the snap of a finger for us to recover from that. Now, deadly plague, I know it's kind of topical. I don't think that we have to worry about a dip like that today with what we're dealing with. In the 1400s, we didn't know anything about viruses or bacteria. We had no concept of hygiene. Washing your hands was not a thing, okay? Hygiene was not a thing then. And so just as an aside, that's why we see that big dip, okay? Today, in dealing with the current crisis that we're in, we have medicine, we have hygiene, we have treatment techniques that are going to prevent a dip like that. So I don't want you to look at a deadly plague that we're talking about here in the 1400s and equate that to what's going on today. It's not the same thing, okay? It's not the same thing. Now, what's the second major event on this graph? It's the beginning of the Industrial Revolution. That's when we realized we could get energy from fossil fuels. We could burn fossil fuels at the beginning of the Industrial Revolution. It was coal. Okay, we realized we could burn coal and release enormous amounts of energy from that. And using that information, we were able to develop huge, huge, huge advances in technology. And those huge advances in technology led to a better quality of living for a great many people and an explosion in our population. Okay, and that's when our population began to grow at an exponential rate. Okay, and the third thing we see there is somewhere in between 1800 and the year 2000, so probably during the 20th century. That's between 1900 and 2000, during the 20th century. Okay, our major scientific advances are there: flight, okay, vaccines, insulin, these major technological and major scientific advances that make our lives easier, that make our lifespans last longer. We all approach We now more than ever in history, we all have a best possible chance of approaching the maximum lifespan of a human being. Okay, now because of these scientific advances. Okay, so because of those advances, we see our population increase even more, even more. Okay, now here's the problem. We know that resources are limited. Is there an upper limit to our population? Is there a point at which our planet cannot sustain any more people? Now, some scientists believe that the carrying capacity of our planet is 9 or 10 billion. Some scientists believe that we've gone over our carrying capacity already, even though we only have 7 billion people, that we've gone up and above. And some scientists believe that what we need to do is we need to develop new technologies that use our resources in more sustainable ways so that we can leave our natural environment as untouched as possible, but still continue to feed and heat and power our societies. Okay, so there's really 3 ways of looking at it. Do I have an answer to that question? Do I know? Does anybody know? No. No one knows the answer to that question. No one knows whether we've hit the carrying capacity, we've gone over the carrying capacity, or if we have the further ability to expand the carrying capacity. Nobody has that answer. Nobody knows. All we know is we have to start thinking about ways, because our population is growing at such a huge rate, we have to think about ways that not only can we increase our carrying capacity to make sure that everybody is living a fair quality of life on this planet, okay, but that we're using our resources in a sustainable way. And there are solutions, okay? Right now, we power cars predominantly with gasoline. Is it possible to build cars that run on electricity? Yes, it is, okay? Yes, it is. It is possible, okay? We talked earlier about how the sun has an enormous amount of energy that hits planet Earth, and that just a small fraction of that energy is used to really power all the living things on this planet. Well, there's lots of light. Is it possible that we can figure out equitable ways to harness that solar energy instead of using coal or natural gas in our power plants? Is it possible? It's possible. Yeah, there's technology there that exists or is very close to being developed that could do that in a sustainable way. And in all likelihood, some of you listening right now are probably going to end up in industries or in research positions where you're answering these questions. How can we live more sustainably? And I hope that for a great many of you, okay? But it is a problem that we need to solve, and that's what we do in science. We solve problems. Okay. Yeah. We talked about this point, right, about increasing exponentially until we hit that carrying capacity, that upper cap. Okay. There's an important word in this sentence, and it's exploitation. Okay, exploitation. Yes, our technology and our science and our research has developed public health, which is kind of like hygiene and medicine. Okay, education, agriculture, medicine, technology. All these things have led to us being able to increase our carrying capacity, allow more and more people to live on this earth, okay? But it has come at a cost. We have exploited a great many places and a great many natural resources on this planet and depleted them. And we continue to do that. And that's something that we have to really, really avoid. The other thing that I want you to think about is, does everybody on this planet live with the same quality of life? And I think that we know the answer is no. We have great access to public health. We have great access to education. We have great access to food here in Canada. Not every country in the world has the same access. And so not every person has the same quality of life. And that's something that we have to think about, is that we don't just want to improve quality of life for the people that are living in wealthier developed nations. We want to make sure that we're developing technologies and methods that will make life equitable for as many people as possible. Okay. Doubling time. What does doubling time mean? Now, you've probably heard this now because we're sort of living through this viral pandemic where we're talking about the number of cases doubling. Okay. And that's not what we're talking about here. What we're talking about here is a population overall and how long it takes that population to double. Okay. So let's take a look. I think I have an example here. Until about 400 years ago, human population growth was slow and steady. We saw that in the graph. Okay. From the early 1600s to the 1800s, the human population doubled from 500 million to 1 billion in 200 years. That means the doubling time was 2 centuries, 200 years. Okay. Today, that doubling time is not 200 years. Today, that doubling time is probably closer to 50 or 60 years. Okay, so we need to bear that in mind. That is huge population growth. That means within your lifespan, okay, from now until when you're retired, okay, when you've worked all your life and then you've retired, you will have seen the population of this planet double. Okay. What's our ecological footprint? It's a measure of the impact an individual or population has on the environment in terms of the energy that we consume, the land that we use, and the waste that we produce. Okay. Okay. Now, ecological footprint can be something that we refer to animals or plants. They produce waste, they consume energy, they take up land. But I think right now in our headspace, we're thinking about us as a species and the amount of energy we consume, the land that we use, and the waste that we produce. Okay. Now, we live in a developed country, that's Canada. We have huge ecological footprints. Okay. And in a world that has finite resources, what does finite mean? Well, we all know what infinite means. Finite is the opposite of infinite. That means there is a limit to the amount of resources that we have. Okay. And again, I mentioned this, not only are our resources finite, we're dependent on resources that are non-renewable, fossil fuels. When we use them all, they're gone. Okay. It took millions upon millions of years for living things to die, become buried deep beneath the surface of the planet, and then become crude oil for us to use, or coal for us to use, or natural gas for us to use. It took millions of years for that to happen. Okay. It's unlikely that in our lifespans we're going to get more crude oil than already exists in our planet right now, and we're using it at a rapid rate. We're going to run out. Okay. So our practices are unsustainable. And that means a pattern of activity that leads to a decline in the function of an ecosystem. Okay, a pattern of activity that leads to a decline in the function of an ecosystem. If our ecosystem is the planet Earth, okay, that's our ecosystem, because we live almost everywhere on planet Earth. And there are people living in Antarctica. There's probably a handful of people living there in research positions. But generally speaking, every other continent has huge populations of people. Okay, and so the human ecosystem is the whole planet, and the resources that we're using and the choices that we're making and the activity that we're engaging in is a pattern that will lead to our resources being depleted, and it will break our ecosystem in such a way that it can no longer support life as we know it. Okay, so our practices are unsustainable because they will lead to an ecosystem that can no longer sustain life as we know it. Okay? Life may persist, but not life as we know it. Okay? Here's a nice little table. This table is ecological footprint, and so on the x-axis, you're going to see different countries so that we can compare the ecological footprint of different countries. Okay? And then on the y-axis, it's hectares per person. That essentially means how much space each individual living in the country gets to themselves. Okay. So the global average, it's hard to see, but there's a little dotted line on the right-hand side of the graph above China and India. That's the global average. And it's pretty low. The global average looks like it's just over 2 hectares per person. That's how much space. Now, how much is a hectare? You don't need to know. It's not about knowing how much a hectare is. It's about comparing each of these different countries and saying which countries fall below the average, where the average is, which countries are above the average, and how far above those countries are above the average. So what's a hectare? Don't worry, you can look it up if you want, but it's not important. It's not the concept here that we're trying to get. Hectare is just amount of space. So think about amount of space. So if the average amount of space around the planet, the global average is just over 2 hectares, 2 units of space. We have a couple countries there, China and India. They have just over 1 billion people living in each country. Okay, they're below the global average in terms of space. As we go to the far left of the graph, you're going to find the United States of America at the top, where people have an average of 12 hectares or use an average of 12 hectares of space per person. That is 6 times the global average. Okay, so let's compare the global footprint of people that are living in the United States to people that are living in China or India. It is huge. And Canada is not that far behind. Canada is, let's say, better than the United States. Our footprint is lower, but our footprint is about 8 hectares per person. So we're still 4 times the global average, or maybe 3.5 times the global average. Okay, that means that our footprint here in the developed world, United States, Canada, some of the other westernized nations, Australia, we're using much, 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 much more of our resources than other people around the planet are using. Okay, that means the vast majority of people have nowhere near the amount of resources that we have in North America. It's an unequal distribution of the resources, and that impacts our quality of life. Okay, we have a great quality of life because we're exploiting our resources to, between 4 and 6 times the global average. Other countries have a lower quality of life and fewer resources available to them because we're taking all of those resources up. Okay, is that fair? Is it right? That's a question that you have to ask yourselves. So here's a point. Modern societies must seek to establish ecological footprints that reflect the principles of sustainability. If the United States is using 6 times the global average in terms of ecological footprint, is that sustainable? Probably not. Okay, actually, definitely not. Okay. So sustainability should be the use of Earth's resources, including land and water, but not limited to land and water. We're talking about all resources here, okay, in such a way that our use can continue forever. Do you think that in the Western world, we can continue to use resources at a rate 6 times that of the global average and continue using those resources at that rate indefinitely or forever? I'm afraid not. Okay, so we have to come up with more sustainable methods to use our resources so we can minimize our footprint. Okay, here's a question for you. What are some ways you can reduce your ecological footprint? And they're not hard questions. It's a lot of it's common knowledge. I'm going to make sure I turn lights off in my house because the lights use electricity. That's energy that's being produced. I'm going to walk to places instead of driving to places. I'm going to carpool to work instead of driving myself to work. Okay, the average car weighs 2 or 3 tons, right? 2 or 3 tons, and most people take one person in a car to get to work. It takes a lot of energy to move that car, which weighs 2 or 3 tons. Burns a lot of fuel to get that car from home to work, right? Is there a more sustainable way to do it? Maybe. Yeah, I think probably. Okay. Ecosystem services are benefits experienced by organisms that are provided by sustainable ecosystems. So these are not ecosystem services that human beings provide at some office. Okay, they're not services. They are what the ecosystem provides. Okay, what we get from a natural ecosystem. Okay, when it is sustainable. And it's a very important list. I'm going to read that list so you can hear it and you can read it. The first is that ecosystems provide food and clean water. We need to eat and we need to drink. Okay. Ecosystems influence climate. Our climate on planet Earth is very temperate. I know some places are quite cold, some places are quite hot, but on average, this planet is very, very livable. The climate, the temperature, and the weather patterns allow us and many other organisms to survive. There are no other planets in our solar system that can support life. Okay, so when we change our climate, when we have a direct effect on our climate that makes it less sustainable, that's not good. Okay, we should not take for granted the fact that our climate is suitable for life. Okay. The third point is the cycling of nutrients. It is like we talked about the nutrient cycles prior, the phosphorus, the nitrogen, the carbon, and the water cycle. These are nutrients that all life requires. And our planet, the natural ecosystem, acts like a filter, making sure that we can obtain these nutrients, use those nutrients, and then get cycled back into the natural ecosystem so that process can continue indefinitely. We break that cycle. We prevent that cycle from ongoing indefinitely, okay? The conversion of atmospheric carbon into biomass, well, that's wild. We take carbon dioxide, which is inorganic. Carbon dioxide is an inorganic molecule, and our ecosystem, particularly plants, allow that carbon to be taken in from the atmosphere, turned into sugar, and then consumed. Okay, so that we can grow, we can produce energy, and we can survive. Okay, takes that carbon dioxide that's inorganic and makes it organic. It allows crops and vegetation to be pollinated, right? Now we know that bees pollinate plants and hummingbirds pollinate plants, and that the wind can sometimes carry pollen, and that's how plants reproduce. That's a process that happens without our intervention. Okay, and sometimes we can get in the way of that intervention. Okay, and I may post an article. I usually do an assignment on it about bees and their importance. And I may not put the assignment up on LMS, but I may post the article. I don't know. I haven't decided yet. I may just post the questions that go with this, the assignment, just so that you can read them and not necessarily hand it in, but you can read the questions and help you to digest the article that I post. We'll see about that. I haven't decided yet. Okay. Reducing erosion in watersheds. So erosion is when land gets gradually weathered by water. Okay. It provides habitats, places for a lot of organisms to live. It balances out growth and decomposition. And it provides beauty and spirituality. It's just nice to look at. It's nice to exist, and it puts us at peace. Okay. So it's very important to maintain our ecosystems for those 9 reasons. And we interrupt that an awful lot. Okay. Influence of forest on climate. Trees take out water from the soil. Okay. And when it's hot, water escapes. We talked about those little stomata, those little pores at the bottom of leaves. Okay. On hot days, water can actually escape those pores in a process called transpiration, and that pushes water into the atmosphere. Okay. Water vapor, not water as liquid, water is a gas. Okay. And that actually reduces temperatures and forms rain clouds. Okay, so that keeps the temperature nice and moderate. Okay. When large forest areas are cleared, okay, when it gets cleared, what happens is those plants, those trees, well, they're no longer there to introduce that water vapor into the atmosphere. And so the air gets drier, and when it gets drier, it gets hotter. And that causes something called desertification. That means that the area that we clear cut all the trees down, becomes closer to a desert. Okay, that means we're taking an area that's not a desert. Okay, we're clearing it. Okay, and we turn it into a place that is like a desert. Okay. Now, the problem is that can result from climate change. When we enhance the greenhouse effect, cause temperature to rise, that means that the forest itself may die out or burn out. We've seen that happen in California and Australia. Okay. Or it can happen because we're using too much water, and that water is getting sucked away, that groundwater is being sucked away from plants and trees. Or it can happen because we clear cut because we want to farm. Okay, and so those 3 things can lead to desertification. Forests and watersheds. Here's what a watershed is. It's an area of land over which the runoff drains into a body of water. So we talked about runoff. We talked about how when it rains or when it snows and the snow melts, that water will run back to the nearest large body of water. And there are lots of, I mean, this happens everywhere. That runoff happens everywhere. But there's areas where There's areas where the water will begin to collect on land. It'll get closer and closer together, and those places are usually wetter. Okay. Watersheds that have been cleared of trees have 30 to 40% increases in runoff. Okay. That means the soil isn't as likely to retain water. So we want some of that water to end up back in the large body, but we want some of it to end up in the soil because organisms need that water in the soil to grow. Okay. If the soil can't retain water, then it also can't retain nutrients like nitrogen. So see how this is gotta think of it like a domino effect. Okay. If we get rid of the trees, then the soil can't hold the water. If the soil can't hold the water, okay, then it also can't hold on to nutrients. Okay. And then if we get rid of the trees, well, then the trees can't be there to regulate climate. Okay. So we have all this domino effect of things that can go wrong because we've cut down trees and watersheds. Okay. And there's just a diagram that kind of shows you where a watershed boundary might be, and you can kind of see it. It's labeled here at the top of the diagram. Okay, how it's sort of an area in between some mountains where a lot of water tends to collect. Okay, it's sort of an area where water is more likely to connect and then head into the large boundary. That's a watershed, and they're typically places that are a little more moist. And you see, if you see how the hills tend to make that area more conducive for runoff collecting in that area, that's how one way we might recognize that we're in a watershed is that there's some natural geographical feature that makes it more likely to be a watershed. I also want to point out one more thing in this diagram that I'm just noticing. That is at the bottom of the diagram, you see that there's groundwater, okay? And there's a place at which there's a limit of fresh groundwater, and then there's salty groundwater. We cannot drink salt water. We drink fresh water. Most organisms need fresh water, not salt water, okay? So it's important to make sure that there's a distinction between salt water and fresh water. Now, what are we going to do with that distinction? Nothing on this slide right now, but I just want you to bear in mind that that boundary, there's lots of water there, but if it's salty, it's very difficult for us to use. Okay, it's very difficult. It's actually impossible for a lot of other organisms to use. For us, we can actually desalinate water, but it takes a lot of money and a lot of energy to desalinate water, take the salt out. But natural organisms can't do that. Okay. They need fresh water to survive. Okay. Here's a fun statement to say. Plants reproduce through sexual reproduction, not the same way that people or animals do. Okay. Plants often have both male and female sexual organs. Okay. The male part of the plant produces pollen. Okay. And that pollen fertilizes a female ovary in another flower of the same species. Okay. So plants rely on this pollen being carried from one flower to another. I mentioned this earlier when I talked about the bees. I forgot that this slide was coming up. Okay. So the most common pollinators are actually bees. We think of them as the most common pollinators. Other insects do it too. Hummingbirds do it. Different insects do it. Hummingbirds do it. As they go from flower to flower, okay, they carry pollen with them. Bees typically carry it on their hind legs. The pollen attaches to their hind legs by accident and then gets carried from flower to flower. Okay. Cross-pollination can also happen by the wind. So that's why people who have pollen allergies, well, in the spring, they start to sneeze an awful lot, start to feel uncomfortable because there's a lot of pollen in the air because the wind is blowing that pollen from plant to plant. Okay. Now, plants can also pollinate themselves. Okay. Or other flowers on the same plant. You know, one plant can have many flowers. That can happen as well. But again, same processes. You need the wind to blow pollen. You need a bee or a hummingbird or some kind of organism to carry that pollen from one flower to another. Okay, so we really have those two forms of pollination: cross-pollination, self-pollination. That means we're going from one plant to a different plant of the same species, or a plant is fertilizing itself. That can happen. Okay, but it's all sexual reproduction because it involves male we would call them male, for lack of a better word, parts of the plant, and female parts of the plant, for lack of a better word. Okay. So productivity is a lot better when pollinators are doing the pollinating and not the wind, because you know the bee is going to head from one flower to another flower. You know that's going to happen. Okay. The wind, when the wind blows pollen, is just you're rolling the dice. Okay. It's by chance that you end up pollinating another plant. Okay. And it happens, and it's perfectly efficient, but it's much more efficient when it's through a pollinator. Okay. So that's important. Now, you learn more about plants in later biology courses, the concept of plant reproduction, okay, and also the process of plant sexual reproduction comes up later. Right now, all you need to know is we need pollen from one plant, okay, from the male portion of the plant, the flower, and it needs to enter the female part of another plant, okay. Okay. The graph below shows two examples of plants that produce more seeds when they are cross-pollinated than when they are self-pollinated. Okay, so remember, cross-pollinated means we're going from one plant to a different plant of the same species. Okay, and self-pollinating is it's the same plant, might be different flowers, but on the same plant. Okay, so what we can see from this graph, both graphs, because it's two different plants, is that plants are they are much more fertile. They grow much better when they're cross-pollinated than when they're self-pollinated. Self-pollinated will grow more plants, but we prefer cross-pollination because we get an even bigger yield. We get more seeds out of that. Okay, so that's just to bear in mind how important it is for those insects or those hummingbirds or those bees to interact with flowers and other plants, because we get more seeds, okay? We get more growth. Really, really important. Okay, all living things die. I'm sorry. Okay, it's a natural part of life. Benjamin Franklin once said the only things guaranteed are death and taxes. Okay, so everything does die, and it's an important process. It's actually biologically very, very important. It's so all the nutrients that are in a body, okay, whether that's an animal body, whether that's a plant matter that has died, okay, has to be recycled. Everything that's within that living thing, when it dies, has to be recycled, returned to the ecosystem, and then recycled and cycled through. Decomposition is the process of breaking down things that are organic. Okay, and that's a relationship between a living organism and a dead one. So there are a lot of organisms on this planet, and many of them are gross. Okay, but there are a lot of organisms on this planet that are considered decomposers. Okay. Now, decomposition ensures that nutrients are returned to the soil and the water and the air when dead organisms decay. And that's why insects, bacteria, and fungi, like mushrooms, okay, are very, very, very important organisms. Sometimes they're very gross. Sometimes the process of decomposition is disgusting. And you can go on YouTube, and maybe, if I remember, I'll post a video of stuff being decomposed, and I'll post it on our LMS. You don't have to watch it if you don't want to, but if you do want to, you can see things being decomposed. It is disgusting, okay? But it is a very, very, very important process because it recycles those nutrients, okay? It maintains that balance, okay? It is a sustainable practice so that whatever nutrients are in a body that has died do not remain in that body. They continue to be used by the ecosystem in one way or another. Okay. Here's a nice little picture. I'm not going to get too deep into it. It's really a dead mouse, and you can see how it attracts bugs and maggots. What happens is the beetles start to approach it, and they'll actually lay eggs, and the eggs are on the decaying body and use that to feed the growing larvae. So there is balance here in this diagram, that when something dies, it allows other things to live, and those other things return those nutrients to the natural environment. Is it pretty? No. Is it necessary? Yes. Okay. Habitat, recreation, beauty, and spirituality. Okay. Ecotourism is tourism that is sensitive to the health of an ecosystem and involves recreational activities provided by sustainable ecosystems. Okay, there are many ways in which we can get recreational enjoyment from ecosystems. We can go for a hike. Not now. We can't go for a hike right now because we're in a lockdown. You cannot go near any hiking trails right now. You'll get a fine, and a fairly substantial fine. Okay. But hiking, snowshoeing, fishing, kayaking. I used to camp all the time in Algonquin Park. And it's a very sustainable practice, but it gives you the opportunity to enjoy the natural ecosystem, to see animals in a natural habitat. Although don't get too close. I have seen bears in real life. Without offense, in between us, it is not fun. Okay. Others appreciate the beauty of the landscape of sustainable ecosystems through art and photography. Okay. And I think we agree with that. I think we see a beautiful picture, nature photography, and it's lovely to look at. And some of us like to take those pictures. Some of the great artists, they were doing paintings of just natural landscapes. If you are interested in art at all, then you need to look up the Group of Seven and Tom Thompson. These were artists that used to go up into Northern Ontario, into Algonquin Park, and they used to just spend days and weeks in Algonquin Park painting and producing works of art that that represented the Canadian landscape and the Canadian Shield up there in Algonquin Park. Just a personal recommendation, but there are lots of other examples of artists painting landscapes that end up being quite iconic and quite important. Okay. In particular, Canada's Indigenous people have a long-lasting, complex spiritual traditions connected to the ecosystems they occupy. Okay, now I think you probably learn a little more about this in geography, maybe, or maybe in religion class at some point, whether it's grade 10 or 11 religion. You may learn about this. But Canada's Indigenous people, there is a lot to learn from the Indigenous people of Canada in terms of the way they interact with nature and the way they respect nature and appreciate nature. And so I urge all of you to take that very seriously when that comes up in, I can't remember which religion course it is, I can't remember which geography course it is, but when it does, please appreciate that. Okay. And I think that's it for today. That's going to be it for lesson 6. So hopefully we're keeping up with these notes. I'm thinking that this is probably going to be posted sometime around, I don't know, April 13th or 14th. I'm not quite sure yet. But this is lesson 6. And so I had mentioned before that we were going to have a quiz between lesson 4, 5, and 6. Well, I'm going to post a review. Hopefully that's posted already. There should likely be right now a quiz that is available on LMS or will shortly be available on LMS depending on when I posted this video. So keep an eye out on the announcements for that. And otherwise, stay healthy and stay safe. Take care. Bye-bye.